The reticular formation. The reticular formation is a network of neurons that are scattered all over the brainstem. You can see all these arrows, they are indicating the reticular formation. The reticular formation relays the information to the thalamus. The thalamus then relays the information to the rest of the brain. It relays information that it receives, for example, from the ears and from the eyes, and also from lower areas of our body, such as our arms, cardiovascular control. Other functions are pain modulation, sleep and consciousness. You can go into coma if you have damage to this area. The cerebellum. The cerebellum is behind the brainstem, below the brain. So a cut to the cerebellum show you that it has these areas. They are called the arbor vitae. That looks like a little branches of a tree. Okay, that's what you have inside. The outside of the cerebellum, it shows you that it has lobes. This part is the anterior lobe. This part is the posterior lobe. It also has hemispheres, left hemisphere and right hemisphere, and they're connected by the vermis. The cerebellum helps us control equilibrium as well as coordination of movement. It has some very important cells, such as the Purkinje cells. They are very big cells that you are going to have in your cerebellum, as well as granule cells. The diencephalon. The diencephalon has three parts: thalamus, hypothalamus, and epithalamus. The thalamus is a group of neurons. They're going to form multiple groups. The thalamus is located right in the middle before the information reaches the brain. A lot of times in the book, you're going to see that this is referred as the gateway to the brain, because all the information that you have coming from the body, from the ears, from the eyes, from the cerebellum, from the reticular formation, they're going to go through the thalamus. The thalamus processes all the information and relays this information to the different areas of the brain. The hypothalamus. The hypothalamus also forms groups. Two of the most important functions about the hypothalamus is that it controls everything that got to do with hormones and with the autonomic nervous system. Every single hormone that you have in your body is going to be controlled by the hypothalamus. So it has a very important function with respect to maintaining homeostasis of your body. In addition to that, you have control of hunger, thermoregulation, food intake, relation with the sleep, as well as memory. The epithalamus consists of two main parts. One of them is the pineal gland, and the other one is the habenula. Habenula is part of the limbic system. The pineal gland is going to secrete melatonin, and is going to be necessary in order to control the circadian rhythm, which helps us distinguish between what is day and what is night. Cerebral white matter. The white matter represents the axons of the neurons, and they go down and they go up, and this is the ones that we already covered in the spinal cord. We said these ones that go up are ascending tracks, the ones that go down are descending tracks. These tracks, regardless of these being ascending or descending, they're going to be projection tracks. But projection tracks are not the only tracks that you have. You also have other tracks, which are the axons that communicate one hemisphere to the other hemisphere. Those are going to be called commissural tracks, and that's what you see right here. You also have other tracks that are going to communicate different areas within the same hemisphere. So for example, this part with this part, and those are going to be called association tracks. Brain, the cerebral cortex is divided into hemispheres. This is one hemisphere. On the other side is going to be the other hemisphere. But it can also be divided in lobes. We said this is frontal lobe, parietal lobe, occipital lobe, temporal lobe. There's another lobe called the insula. You need to separate the temporal lobe and the frontal lobe in order to see the insula inside. We also said that the cerebral cortex is not flat like a table, but it has elevations and grooves. The elevations are going to be called gyra, and the grooves are going to be called sulcus. All the coordination and integration of the different type of stimulus that we receive happens in the cerebrum. The cerebrum is divided in three main areas. Those are going to be the cerebral cortex, the basal nuclei, and the limbic system. If we enlarge the cerebral cortex, we're going to see that there are very important cells. Those cells are going to be pyramidal cells and stellate cells. The disposition that they have is in layers at the level of your cortex, the limbic system. So the limbic system is a very important area for emotion and learning. There are multiple different areas associated with the limbic system, and that's what you see right here. Depending on the book that you're going to read, you're going to see that different areas are going to be part of it. But there are three main areas that everybody basically agrees on that, which are the cingulate gyrus, the hippocampus, as well as the amygdala. The cingulate gyrus is this one right here on top of the corpus callosum. Right here, you're going to have the hippocampus, and the amygdala. The amygdala is in charge of or in control of emotion, and hippocampus is very important in memory. The next topic is going to be the basal nuclei. Basal nuclei are a set of neurons that they're going to be located on each side of the thalamus. And you see these ones right here. Those are considered basal nuclei. These basal nuclei are involved in motor control. Okay, the next topic is the integrative functions of the brain. This got to do with functions that occupy most of the brain, such as cognition, memory, and emotions, and sleep. Sleep cannot be studied because, obviously we are sleeping, so there's no way we can communicate what's going on. For that reason, we're going to use an electroencephalogram. Electrodes in the scalp capture the electrical activity in waves. Based on that, you can see here that we have different waves when we are awake, then when we are becoming drowsy, like the sleep, deep sleep, and REM, which is rapid eye movement. Cognition. Cognition is all the mental processes that we're going to use in order to know something, to understand and to acquire knowledge. Around like 80% of the brain is used to achieve cognition. When we have problems in the brain, some areas of this cognition are going to be affected. Memory, short-term memory and long-term memory. Short-term memory is from seconds to hours. So maybe something that you heard today in class, you will still remember it tomorrow. And then long-term memory, the one that is already in your brain, such as your name, you will never going to forget that. And also there are parts from the limbic system that are going to be important in the memory. And one of them is hippocampus. When we were talking about the limbic system, we said the hippocampus is very important in memory. Most of the memories and things that we learn are associated a lot of times with emotions. You smell something, for example, turkey and gravy. It brings memories to your head about Thanksgiving, but it's not just blank memories. It also brings emotions such as the love that you have for your family or being together with friends, etc., etc. And we said that the limbic system is also very important in this part because the amygdala is a major component of the limbic system that is involved in emotion sensation. If you get bitten by a mosquito, you're going to feel that. But that's not the only sensation that you can get. You have also other areas where you're going to sense, such as in your eyes and your ears. The brain, from the anatomy point of view, we said that this is the frontal lobe. This is the parietal lobe, occipital lobe, and temporal lobe, but that's from the anatomy point of view. From the physiological point of view, in other words, by the function that each one of these lobes are going to have, you can see right here that this is the area where we're going to process information that comes from our eyes, because this area right here is for vision. Yes, from the anatomy point of view, what is this? This is the occipital lobe, but from the physiological point of view, from the function, from the special senses, this is the visual area. But you have other areas, such as language, auditory areas. We have them right here, for example, in the temporal area, primary auditory cortex. Sensation that we have in our skin are going to be controlled by the primary somatosensory cortex. So if something in your arm itches, that information will go up to your brain into this area right here. Now you need to scratch it. These neurons will make a synapse with these neurons right here because this one is the primary motor cortex. So you can send the information down through the axons into the muscle so you can scratch it. So this is the primary somatosensory area because this is going to make you feel your skin, for example. And this is the one that is going to be the primary motor cortex because this is going to help you move your muscles. This is the central sulcus, the longest sulcus that we have. So this is going to be the precentral gyra. Precentral gyra is going to be motor. And this is going to be the postcentral gyra. This is going to be sensory. This is called the homunculus. This is just a graphical representation of the number of receptors that we have in our skin. For example, where do you have more receptors, in your hand or in your arms? As you can see here, there's more receptors in your hand. Let's say since you have more receptors, then you have a bigger area in your brain that is going to help you process the information that you receive from your hands compared to, for example, what you have in your forearm. Language. There are two main areas. One of them is Wernicke area and the other one is Broca area because you need to understand language, and the other one is that you should be able to actually speak. So that's why we have two completely different areas. One is to understand and the other one is the ability to talk. Cerebral lateralization. The right hemisphere and the left hemisphere is not that one of them is more dominant than the other, but rather one of them is more specialized in certain things compared to the other. Okay, some people are very good at math, for example, because one side is very specialized on that, but some other ones are singers, right? And they like to sing and they compose music, for example, and they have the other area of the brain more specialized on that.